application of doing the derivative is finding the graphs of derivatives. So remember that the derivative of a function, differentiating a function, will always give you the slope of the tangent line. So if you're given a graph of a function, so let's put up an example function here that maybe looks something like this. The graph of the derivative will look like the slope of this function at every point. So I'm going to do this part in yellow. So yellow is signifying the derivative here. So when you're trying to graph a derivative, you first want to look at some key points. So what are the easiest points to determine on this? Well, anytime you have a minimum or maximum on your original graph, your derivative, the slope of your tangent line, is going to be 0 because the tangent line would be horizontal. So we know at this x right here, our derivative has to be 0. And at this x right here, our derivative has to be 0. Now most of the time you get a question like this on a test, you're not going to be asked to be extremely precise. They just want you to get the key points down and have everything else correct. So let's think about what else the graph might be doing. Well, any time before this x where we already said the tangent line would be horizontal, our tangent line is going to be positive. And in fact, it's getting less and less and less positive all the way till it gets to 0. So that tells us that our derivative graph is going to have to look like that. It starts out very positive, and gets less positive, and hits 0. Remember, we're talking about the value of this. We have the slope of this yellow line has no bearing on anything for this problem. Now, once we pass this point, now our slopes are negative, so the value of the derivative should be negative. But it comes back to being 0 here. So this is going to look like this. And finally, past this point, our derivative is just positive. So it's going to look like, it's going to increase like that as well. So this yellow line right here was our f prime of x. The white line was just our f of x. And this would be an example of how to graph the derivative of a function. So all you really need to look at is what is the slope at any given point, and essentially just graph that. Now, like I said, I didn't draw any numbers on here, and typically on a test you're not going to have to either. You just need to know that this is positive, getting less positive, so it must be a line that's sloping downward like that. However, the points where your function has a horizontal tangent line, meaning the derivative is going to be 0, those are things that you should be able to specifically put on the graph, and you can base everything else off of that. So this is an example of how to graph a derivative of a function.